The good news is that we have some amazing representation from the New York-based Google Glass community. And I'd like to introduce a special guest today. Put your hands together for Ellen Firstenberg.
First of all, I'd like to thank you guys for having me here today. I know glass is not always a good word in the augmented reality community, so I'm glad to talk to you a little bit about this. And I'm going to be talking about thinking for glass. One of the things we see a lot of is that people who approach developing for glass aren't really thinking in terms of glass. So we'll talk a little bit about what that is. First, a little bit about myself. My name's Alan Firstenberg. I'm a software developer. I do mostly business back-end type development. I got into glass totally on a whim because I thought it looked neat. And now I'm one of the first people to have published glassware that's available through Google's My Glass store. I'm a glass explorer. I've been doing this now for almost a year. I was part of the hackathon where Google first presented glass to a small group of developers. I was lucky enough to get into that, and I was hooked immediately when I first put glass on and started developing for it. It was leveraging so many of the things that I had been looking forward to for decades almost that it immediately grabbed me. Because of all my work, because of how much I've worked with the local New York community, how much I've done things on Stack Overflow, Google acknowledges me as what they call a Google developer expert for glass, which mostly means I don't work for Google. I work with a lot of developers, and I work with all of us trying to create some great glassware. That's my goal, is to help all of us do some great things. And finally, as part of that, I'm writing a book on developing glassware. With me today is Barry Nevin. He's going to be keeping an eye on you guys. If at any point you have questions, please raise your hand and Barry will come over and get you the microphone. I encourage questions. There's a lot here that you're going to disagree with me about, and I want to make sure that we've got a conversation going both during this session and for the rest of the day about what it means to create great glassware, where this particular aspect is going, and what all of you can do as part of it. So when I say we're thinking for glass, what do I mean by that? I tend to divide it into three parts. The first is discovering what glass is about, and in some ways how glass is different. How many of you here have used glass? I see one person with glass. I see about half of you. How many of you haven't used glass before? Okay, so a little bit more than half have never seen it, have never used it. Next, I'm going to talk about what designing for glass is, and that's actually going to be the bulk of my talk, because designing for glass is different than designing for anything else you've dealt with before. It's different than designing for a phone or a tablet. In some ways, it's even different than designing for other eyewear that's out there. And as we're all exploring this space, we're all trying to figure out what makes for good design. Google's given us some guidelines. We've experimented and found some things out, and I'll be covering some of that as we go. And then finally, I will be talking about how do we develop for this? What are we doing? A lot of people look at it and say, oh, it's Android, right? That's all there is to it? No. There's a lot more to it, both making it easier and in some cases making it more difficult. So let's talk at least a little bit, for those of you that have never seen it before, what discovering glass is all about. Let's look at it a little bit. We've got this very brief picture of it here. Has everyone at least seen what glass looks like? The fact that somebody up here is wearing this funny thing on their face isn't totally shocking to you? Okay. What we can see from this is we've got a fairly simple device with a lot of stuff crammed into it. It's got a camera on the front. That camera can be triggered by a button that's on the top of it. Most of what we see here, this surface along the side, is a swipeable screen, so you can swipe forwards, backwards, touch it to select something, or swipe down to go backwards. Very, very basic controls. What you can't see there is there's also a microphone that's pointed at you so that commands that you issue to it take effect. It's mostly voice command driven. The other thing that's a little bit difficult to see from this, in fact, I'm not sure you can see it at all, is the prism that's in front, and I don't know if you can just see that mine just lit up. The fact that it lights up indicates that it's doing something. Most of the time, glass is doing nothing at all. It's sitting there on your face, not showing you anything, not reading anything in your ear, especially not recording anything. So usually, it's in idle mode. And this is something that a lot of people, both people who are designing for it or want to design for it, and certainly people who have never seen it before, have trouble grasping. Glass is mostly out of your way. Right now, it's sitting in my peripheral vision, and if I didn't know that I was talking about it all the time, I will have forgotten that it's there. Most people who wear glass all the time don't think about it any more than they think about the frames that they wear on their regular pair of glasses or anything else that's just always there. Glass is there when you need it and out of the way when you don't need it. And most of the time, you don't need it. It sits up in your peripheral vision. So as it was pointed out earlier, if you actually want to look at it, you kind of have to look up and to the right. There is a lot of reasons why they did this. The first was some of their experiments where they did put it directly in the focus of your vision was causing headaches. It was uncomfortable and unpleasant to use for extended periods of time, and they were looking for something that was going to be used for extended periods of time. So they pushed the display up and to the right. As part of that, that now means I can easily look at all of you, I can make eye contact with the people in the first few rows, and there's nothing distracting me from doing that. By pushing in the upper right-hand corner at the same time, it changes how we interact with the screen. So I'm not going to stare up in the upper right-hand corner of my peripheral vision for 30 minutes at a time. In a recent presentation I did, I asked how many of the glass people in the audience looked at their display for 30 minutes at a time, and nobody raised their hand. I dropped that down to 10, and nobody raised their hand. 5, I got 1 or 2 people raising their hands once in a while. When I got down to 1 minute, I had a few other people saying, yeah, once in a while. Most interactions with glass by looking at the display take about 5 seconds at a time. And almost all interactions take far, far less than that. Glass is a glanceable user interface. Most people will hear a chime. That's the other thing you don't see here, is there's a bone-conducting speaker. You'll hear a little chime indicating you've got a message. You'll nod your head to wake it up. You'll take a quick glance to see if this is important. And if it's important, you'll take action on that. That action might be telling it to read it out loud to you. It might be touching it to read it out loud yourself. Or it might be you concluding that this is so important, you're actually going to pick up your tablet and use a better device to interact with that piece of email that just came in. So, any questions so far on how people tend to use glass? Seeing none, I get to move on. When it comes to design, we have 5 basic design principles that we urge all developers to pay attention to really understand. And I'm going to go into all 5 in greater detail. But they boil down to something that's almost obvious. You need to design for glass when you're designing for glass. And this seems obvious, and yet it's amazing how many people don't. A lot of people, when they first start looking at how they're going to be developing, they say, okay, well, this is Android. I'm just going to take my Android app, and all of the user interfaces that I used on Android, I can now have on glass. Well, the 5-second glanceability rule kind of says, no, you don't. Don't get in the way. Glass, as I pointed out, lets you establish eye contact with the people around you. Your app can't break that trust. You need to make sure you keep it relevant. You need to make sure that you're avoiding the unexpected, or when you do something unexpected, that it is a pleasant surprise. And finally, glass is built for people. People are using this. This isn't something that they've got on their PC that you're expecting them to learn how to use. You need to adapt to how they're doing it. So what do we mean by designing for glass? The core concept here is, as I pointed out, micro-interactions. You're supposed to be complementing other devices. You can't assume that glass is going to be the only thing that a user will ever use or ever want to use. So one of the things we often see, that we often talk about, is data in the cloud lasts forever. If you want to access something that happened last year, you go to the cloud storage. 10 years ago, you'll pull it up on the web. Your PC or your laptop and your phone have much shorter time periods that they've got things stored in. So your desktop computer might have stuff that you've got on for the last year, and that's a very good user interface for you to access this stuff. Your phone's got a smaller capacity and a smaller keyboard, and it might be easier for you to access things there only for the past month or the past week. Glass is really good at accessing things that just happened, are happening now, or are about to happen. And that's pretty much it. We have a concept of what we call the timeline. Glass has a number of cards that range from the things that are going to happen in the near future. When you wake it up, it shows you the current time. And then you look at immediate things that have just taken place in the past in the timeline. That timeline goes back about a week, but you can't assume that it's going to. It can disappear at any time, and one of these other devices will still have the information for you. So glass doesn't work on its own. It's a standalone device. It can work by itself, but you can't assume that the person will always be using just glass to do it. Any questions on this one so far? Wow, quiet crowd. Don't get in the way. This is, I realize I'm in a really tough audience here with this one. Glass's goal, as they designed it, in putting the display in the corner, in pretty much a lot of how the audio, the video was all set up, glass was not intended to replace reality. It's intended to supplement it. It's intended to let people live in the world that they're living in, enjoy the world that they're living in. But when they have questions, when they need to take brief reasons to break away from the reality to help them understand reality better, glass is suited to do that. And here's a quick example of people, in theory, looking at the jellyfish at an exhibit. This might be a good time to either ask for the Wikipedia article on jellyfish or just have that article sent to them automatically, giving them the opportunity to learn more without having to break them away from the beautiful display that they're seeing at that moment. We want to keep things relevant, both in time and in space. So we want to understand what a user is doing at that moment, at that particular place, and give them the information that's most relevant to them then. Might be a little bit difficult for you to see. The top picture illustrates a concept card. Actually, I believe that's a real card, telling a person who is rushing through an airport the status of their flight at that moment. Now, Google knows at that point that you're going to be leaving on a flight. It knows what flight you're leaving on. It's pulled up the gate information, the on-time information, and it's presenting it to you just at the moments that you need it. On the other hand, the bottom slide, this one is a concept card, knows that you've now taken that flight. You're now at your destination. You've gotten off the plane, and what you're most interested in is where is your baggage. So it's now directing you to the bag as opposed to telling you, hey, your flight is still on time. Well, that's great. You knew that already. So it's making sure that we come up with the right pieces of information at the right time in the right place. Avoiding the unexpected. This is actually one of the more difficult ones, but I like to remind people of it a lot. Glass needs to do something that's next to impossible. It needs to read your mind. It needs to know exactly what you want before you want it. It needs to know that you care about a particular piece of advertising or a particular flight that's incoming or outgoing. It cannot surprise you with any of these things. Or if it does surprise you, those surprises need to be pleasant. So on the left, we have a great example of an unpleasant surprise. That would be at 3:30 in the morning, you have your alarm going off to tell you about the early bird cabbage special at the local store. What are the chances are that you really care about that? Pretty slim. But it's amazing how many application developers think, oh, hey, I'm writing an application, the user's installed the application, they're going to want to know everything I tell them, right? Right? How many of you actually would care? Yeah. And as much as we like to think that our users care about everything that our application is sending to them, they don't, and we need to remember that. And finally, we need to build for people. We need to remember that unlike most applications that have been built in the past, Glass is living in our world. We are not living in Glass's world. This is, in some ways, a revolutionary thought process when it comes to programming computers. All the way back to mainframes, people had to learn how to program punch cards. On PCs, people had to learn the arcane keyboard combinations to do anything. When the Mac came in, people needed to learn, what are those funny squiggles on the screen and what do they mean? When it comes to tablets, we've had to learn, when are the keyboards going to come up? What are they going to do? More and more, we've been getting closer, and we've been making these things as easy as possible for people to use. Glass tries to turn it completely around. It fails in some way, I should point out. But it tries to turn it completely around and says that instead of me having to learn how to do something in Glass, Glass should learn what it is I want to do and give it to me at that moment that I really want it. Any questions on any of these 5 design principles? Come on. Okay, one. Good.
Aside from the love story, how close is the operating system in her to an operating system that you'd like to see for Glass?
I regret that I haven't actually seen her yet. From what I've gathered of it, though, it's actually in some ways fairly close. The best current example I can give about the living in our world and reading our minds aspect is if you take a look at what Google Now is doing, not Google Voice Command Search, Google Now, where it's delivering you cards that suddenly show up that say, hey, I know you're going to be leaving for home within the next half hour. You might want to leave a little earlier because there's traffic today. Those sorts of things, those predictive, those contextual understandings are aspects that all of us as developers need to keep in mind when we're developing for things like Glass. Does that sort of answer your question?
You have to see her.
I know I have to see her. Was there another question? I see one back there.
As far as usability, I noticed the controls are on the right-hand side. 90% of people are right-handed, so that makes sense. I will also take a guess that it's not too hard to order them with the left-hand controls.
Repeat the question.
The question is, and I'm going to summarize the question a little bit. You're basically saying you notice everything is on the right. What about lefties? What about people who are left-eye dominant? The answer is right now, sorry. And the reason why, let me explain a little bit more. Right now, Glass is still in almost a developer preview. The Explorer program is still trying to figure out all of the issues, all of the problems, all of the ways people can use it. They're very aware of the fact that there are people that cannot use their right eye to view things or manipulate things or will be more comfortable on the left-hand side. They're aware of it. It's coming. We don't know when.
So to make it for lefties would probably be an easy step when they want to take it. But as far as vision, some people don't need glasses, some wear eyeglasses, some use contacts. In terms of your lifestyle, or as far as attaching the lenses to the glass.
I'm actually a rarity in the Explorer program that Glass fits over my glasses. Glass is actually more intended for people who wear contact lenses, or had been in the past. About a month and a half, 2 months ago, they announced there were frames that were now available that Glass can be mounted to, that this side portion here would be able to mount to those frames. And just yesterday, they announced an agreement with a fairly big frame manufacturer to work on ways that Glass will be able to mount on that they will do more frame design, Glass will do the technology design. So again, it's not there yet. They're moving forward with it because these are things that they know they have to address.
So you need to develop for the real world application, real time application within 5 seconds. Now, how do you think AR is going to work into this environment for glass? Because it seems right now with such real time data that's going to be in place and need to read the thoughts, the processing power to implement AR, it seems a bit far fetched for me. I haven't used Google Glass yet, so I don't really know the implications of the technology, but I'd like to hear your opinion.
You don't give any tools for mind reading?
No.
There are no AR toolkits for mind reading right now?
It's surprising. I can't find a single one.
Where are all the manufacturers here? Anyone? It's a tricky problem, and part of it is I'll be honest. When I got into glass initially, it was because I had friends who had been doing AR for 20 years, and I was excited to finally begin to experience what they were doing. And the reality is, you don't. The reality is I don't like calling it augmented reality on glass simply because you're not going to be looking at it. You're not going to be seeing these entities popping up to supplement that information. Glass took a very, very different approach to similar things. So notification is part of it, but it's also recognizing the fact that people are going to want to know certain things but not be distracted by other things. So they took the avenue of, well, we don't want to distract them at all, so we're just going to push it out of the way and let them choose when they want to acknowledge something. To give an example, I don't know how familiar you are with Field Trip.
Not at all, please.
Field Trip, it's actually an application for iOS and Android that you can install from a Google project somewhere that basically gives you supplemental information about landmarks and restaurants and other attractions as you pass by them. On Android and iOS, it vibrates when you're near something. On glass, it chirps in my ear. And actually, it chirps in my skull. And if I choose to find out more, I can nod my head, and what comes up on the screen is a little display saying what it was that I've just walked past, and possibly giving me a picture of it. And if I'm interested in more, I can tell it to read the full text description out loud to me. But it's totally on me to ask for that information. It's giving me the slightest, subtlest hint that there is something I might be interested in, and then the rest of the burden is on me. And that's kind of the level of augmentation that we have. And that's a very different kind of augmentation than what you guys are really looking at. Now, I noticed a lot of the vendors are talking about how they're applying AR onto glass. I'll mention that a little bit later in the presentation, kind of where that fits into the entire ecosystem. But for the most part, Google is more pushing the aspect of the subtle hints, the subtle suggestions, and then leaving the video cues for fairly short interactions and then relying on mostly audible cues for the rest of it. I see a question back there, yes.
What do you think the data landscape we need to deliver on these sorts of applications? Maybe do like both hopes and dreams and also nightmares? Are we moving towards a Google-only world? Are they the only company that can do it? Or what do you think that data landscape looks like?
So the question is, you refer to as data so you're kind of asking who needs to own the data that we're going to be pushing down to glass?
How do we get it? How do we deliver it? Is there privacy in that?
Okay, that's a good question. Actually, that actually almost ties into my next slide. So we'll go with that. If I don't answer your question by the end of this slide, ask it again. So when we're developing for glass, we have 3 primary approaches that we have to work with right now. The first is what they call the mirror API. This is a REST-based API. It's server-based. It lives in the cloud. The actions that you take on glass get sent to Google servers. Google servers forward it on to an application server. When the application server wants to send something to you, it again goes through Google servers and heads on the way back. The photos that I take on here, when I plug it in at night to recharge, it automatically uploads them all to Google Plus in a private area so I can review them, do whatever I want with them. But to address that question, yes, it all does sit on Google servers. At the same time, though, it also gives other servers pretty open access to send stuff to Glass if you, the Glass owner, approve of that. And what the design guidelines that we presented previously are largely meant to do is make sure that these service providers don't abuse the trust that you're giving them. And as Google evaluates glassware to be added to the My Glass store, they're evaluating it based on those criteria. Again, to make sure that it's not abused because you're so close to how people are using it, what people see, interrupting people. The second tool that we have at our disposal is what's called the Glass Developer Kit. This was released in developer preview last November, and it's what all of the Android developers were really excited about because it finally gave them permission to install stuff directly onto Glass itself. GDK stuff tends to avoid some of those problems of who owns the data and where does it show up by letting an application itself control whether it goes to Google or not, how much of it gets out, where it goes, who gets access to it, and so forth. Android's permissions still apply. With the Mirror API, a whole different set of permissions still apply, but there are still permissions that apply. So there's at least some level of security on every level about who gets access to what and how. Finally, we've got this final aspect here, which I know a lot of people in the lobby are probably working with. I know a lot of doctors really care about. And that's just treating Glass as this piece of hardware. Google's given us the operating system source code, so they'll take that source code, wipe out what was on Glass, and replace it with their own. And when it comes to that, yeah, you now have ultimate control about who has access to your data because you've just kicked Google off the platform. It's popular, it's got limitations, but it's very popular. Any questions about these three development aspects? 2 minutes, thank you. So kind of my conclusion is Glass isn't augmented reality. It's not trying to be augmented reality, but it does try to do some of the same things that AR systems do, and it approaches it in a different way. I think there's a lot that AR has to learn from Glass's design principles. There's a lot that that Glass has to, that we can also learn from AR. So finally, if there are any other questions, now's a good time, or I will be around. If you're interested in getting Glass, take a look at the first URL. You can sign up for the Explorer program there. You can also see a lot more videos about how it works, how it looks, how it feels, and how you use it. The second URL is how to do development stuff in Glass, both with the Mirror API and with the GDK. Finally, if you want to find me, that's my URL. And if you're interested in becoming part of the Glass developer community, and I encourage you to do so, we've got a wide variety of different stuff that you can find in Meetup. We've got at least 3 different Glass groups, some of which focus on development, others just focus on using it. And I think that's an important thing to understand and appreciate is you don't need to be a developer to use Glass. Any other questions?
Do you see that Glass in the Explorer program has informed Google on their recent concepts for the wearables, talking about the smartwatches and that sort of thing? And what do you see as kind of that killer app moving forward for that? Is it the artificial intelligent assistant? Is it something along those lines that's going to make it popular?
Okay, so you had 2 questions there. The first is, how has Glass influenced Google Wear? And I don't know. I'm not privy to any inside Google information, but I found it very interesting that when I went and looked at the design guidelines for Google Wear, they echoed the 5 design guidelines fairly similarly, and in some cases used the exact same quotes. I think there is a lot to learn. There's a lot of crossover. Certainly, it's Google, which means that we've got 2 people, 2 sub-organizations which didn't talk to each other at all, which are now being forced by somebody to talk to each other. As for what the killer app is, what was the killer app for iOS? I don't think there was one. And I think one of the things that I appreciate most about glass is that every person I've talked to uses glass differently, and that's, in some ways, the killer aspect of it, is that it's become so personal, so useful to an individual, that it has great meaning to them. I do think the contextual information is an incredibly powerful aspect, but I don't think it's the only aspect. Last question.
This may be premature to ask, but how hackable, involuntarily, do you expect glass to be? More or less than your normal computer, your normal webcam, or something else? Because anyone who can hack into it without your knowledge has access to an awful lot of personal information.
Okay, so you're using hackable in a malicious sense?
Yes.
Okay, that's not what I think of when I think of hackable. I think it's got all of the vulnerabilities that Android phones have. Also all of the protections that Android phones have. They've taken steps recently to address some of those concerns. It used to be that you put it on and you have instant access to the entire timeline. Now people can set a password on it. So they've been responsive to those issues. It's a concern. I'm not going to say it's not a concern, but the fact that it's a standalone device with the full security stack of Android behind it, I think is to its benefit. Okay, thank you everyone. As I said, I will be around if you've got further questions. Thank you.